What's going on, everyone? Let me know in the chat if you can hear me okay. Just doing a quick sound test before I start. We'll get going here in about 1 to 2 minutes. Okay, we're going to get going in just a second. All right. Okay, let's get going. So, welcome everybody to the stream. If it's your first time, this is a live stream we do every couple weeks where we talk about various topics. Sometimes we do deep dives on certain things. Today is going to be a C video. So, to start, I'm going to do a few channel updates and announcements, but in the meantime, if you have any questions about C or GCC, C history, Dennis Ritchie, Ken Thompson, Unix, how all that fits together, feel free to ask those questions in the comments, and what I'll do is I'll try to answer them all live on here on the video. So feel free to ask those questions at any point in time. If you ask them now while I'm doing the channel update and announcements, then we're going to do a brief Q&A after that, and I'll try to answer everybody's questions as best I can. So feel free to do that now. As far as some channel updates and announcements, I have 3 topics I just want to cover real quick, and this is always the first part of the stream. I like to just make brief announcements to let people know kind of where we're at and address some of the issues over the last couple weeks. So the first is I've been getting accused on YouTube a lot of removing comments, and the other day somebody told me, you removed my comment, you must not have liked it or whatever. But what actually happened is YouTube sometimes sees a comment and it says, I think this comment is spam. And then what it does at that point is it takes the comment and it posts it in a separate queue on YouTube. And I only look at that queue every now and again because it's not always clear how many items are in there. Sometimes it'll say 1, but there's actually like 10. And this is exactly what happened with this guy's comment. Is I thought I didn't delete your comment. I never delete comments ever. Not one single time have I ever looked at a comment on one of my videos and said, "Oh, I don't like that comment. I'm just going to delete it." The only time that doesn't apply is if people are actually spamming, the channel or self-promoting or doing things like that. Then of course I'll delete it. But I'm perfectly fine if you want to call me out on things, if you want to challenge me on different topics. That's wonderful. I would never ever delete a person's comment. And it just so happened that this comment that ended up in spam was that sort of comment. This person took exception to a couple things I said in a video or a stream, and then he made a comment about that. So I guess all I'm trying to say is I never delete comments. So if you see your comment missing or didn't show up, YouTube probably just classified it as spam. And when I do go in there and I check those comments, I will just approve them all. I don't even look at them unless they are actual spam, and then I'll actually delete them. So that's that. Second topic is regarding these streams. So I never really know if I'm doing things that are useful to people. I gauge usefulness by interaction with the video after the fact, and then of course attendance in the streams, and then any kind of engagement that it creates on my Discord server. But beyond that, I don't know if people really like it. People seem to like it. I kind of do the same thing every 2 weeks. I just do a deep dive on something, and maybe people like that. But it'd be nice to get some feedback from the people that are on these streams, particularly the stream regulars that I see every other Saturday, pretty much without exception. But let me know either in the chat or in the comments of this video or on Discord, if you like the current stream, if you have any ideas for better streams, something I could be doing different, because these are all for you, the people watching this stream, and it should be stuff that everybody likes and things people want to learn or watch me do like a deep dive on. And that's kind of the direction it's headed, is kind of a deep dive. If I don't have a stream topic for a given Saturday, generally what I do is I'll just do some sort of programming, either in Python or JavaScript, and maybe C now, and that'll just be what the stream is. And maybe that's fine with people, but let me know in the chat, in the comments, and give me some feedback on that. Oh, Logan Bateman said, "Can you explain compiler bootstrapping?" Yes, absolutely I can. We're definitely going to talk about that today in this video. No question. The final announcement slash kind of channel update is, you probably noticed I did a Unity 3D video, which is kind of cool, right? That's a totally separate area of software engineering that I had not touched until recently, and that's due to one of my friends and also fellows on Discord, Senior Ducky. He's a professional game developer, so he's been kind of him and I have been working on some stuff, and in the process I've been learning some game design, and I thought I would kind of transfer that knowledge into Engineer Man videos so people can also benefit. So that's where that sort of sudden appearance of game design videos came from, is the fact that I've kind of been working on some stuff on the side with him, and he also checks the stuff for accuracy and things like that. So what I really want to know is, do people like game design? Is that something that everybody wants to get into? And if so, let me know. If I go to an optometrist, will they help me see better? They will. And actually, the 10 Canadian that just came in, that's the person that checks all these videos, and the person that I'm working on stuff with. So thanks a lot for the 10 Maple Leaf bucks. So yeah, that's kind of where that came from. So if you want to see more game design, certainly let me know in the comments, let me know in the chat, let me know in Discord, let me know somewhere, so I know that that's what I should make more of, and I'm happy to do so. So that's it for kind of the announcements section. So I'm going to jump into some questions here. So some of these questions, if I'm going to answer them in the context of the video, I'll just answer them then. Otherwise, I'll try to answer them now. Pukar Gary asked, "Hey, Engineer Man, are pointers assets or liabilities?" So I think the simple answer to that is that they are assets. And I only say that because they're both very useful. And if they were a feature that was not useful, then it wouldn't really be in the language anymore. They would just get rid of them. So now, can they be liabilities? Well, of course. If you do something bad with pointers, you can quickly get into this state we call a memory leak, which is essentially accumulating memory that's never freed. And then once that memory completely fills up and your server's out of RAM, your program crashes, and that's it. So in that case, it's easy to shoot yourself in the foot and turn it into a liability, but I believe it's an asset overall, because without pointers, we'd be in a world of hurt. Logan Bateman, can you explain compiler bootstrapping? Yes, absolutely. Just not right this second. I want to cover that in the context of this video. Question asked, where is C used over C++ these days? So C is often used in things where you require either critical performance or places where C is kind of the only appropriate language, such as some embedded applications. But oftentimes where you see C being used is things like high-performance web servers, of course, operating systems, compilers, and then various other things where C is kind of the most sensible option. But it has a lot of use cases outside. However, C does have use cases, C does have things where you wouldn't actually, I messed that up. There are things where you just wouldn't use C. I guess C has its place, but it also has areas that are not its place. Like you wouldn't see C a lot in, say, web dev. Nobody's making websites in C. I mean, they're using technologies that were written in C, but they aren't like they aren't writing web pages, for instance, something like that. Also, not a whole lot of Android apps are made with C. Those are usually C++, for like game stuff, and then Java for just normal apps. And then, yeah, so C has its place, but it also has areas where it shouldn't be used. Just gonna delete that. Okay. Catacombs asks, I've been writing C and became interested in C++. I enjoy the standard library that it provides, especially strings, but don't do OOP. I prefer functions. Should I go with C or continue jumping on C++? So one of the major things, of course, as you know, C++ is a superset of C. And what C++ adds over C is a lot of what we call abstractions. And the thing with abstractions is sometimes they cause additional overhead. Sometimes they're expensive, either in a larger binary or more clock cycles at runtime, but generally they cost you something. And it's always been, throughout the history of computing, people have always been trying to create languages that are both really easy to write and also really fast at executing. But the problem is you can't generally do that. So you have C kind of at the lower end. C is still considered a high level language, compared to what actual low level programming is. But as you go up from C, it starts getting easier to write, but you start losing execution speed. You have newcomers that are kind of hitting the game. These people like Golang, and particularly Rust. Like Rust claims to add a ton of nice language features at what they call zero cost abstraction, meaning you get all these nice things, but it doesn't cost you anything. And that's a really bold proposal, and it's something that hasn't been done that often. So people are always, and really what it's all about is how smart is your compiler? Because these languages that are statically typed and compiled up front, they are compiled to machine code. And once it's machine code, the machine code has no knowledge of what it used to be. Like when you compile a C program, you can't look at that assembly and say, oh, this used to be C, except maybe, oh, well, I know C, the C compiler compiles code, to this, so, maybe this was C, but there's no, you can't go backwards from it. So once a code is compiled, then that's sort of the end of it. So another question from Pukar Gary: will you call Ritchie a genius, or is he similar in position to people like Bjarne? I'm assuming Bjarne Stroustrup or Guido van Rossum. Those two guys. Bjarne Stroustrup was the creator of C++, and Guido van Rossum is the creator of Python. For people that don't know, was Ritchie a genius? No. I think he's in the same class as Bjarne Stroustrup and Guido van Rossum. But what Dennis Ritchie got correct was he kept the C code standard small. And that was the best thing he ever did, because C is not bloated. And oftentimes that's one of the things people complain about, and it's also why C code is so tough to write, is because you don't get a lot of standard features. However, you do get enough standard features to build anything you can possibly imagine. And of course the proof of that is in the fact that like Linux is written in C, and Linux can do literally everything. So C is good enough to make an operating system, and if C is good enough to make an operating system, then it's certainly good enough to make anything else. And so that's what he got right. Bjarne Stroustrup came in and said, I'm going to make C++ because C is not friendly enough. C does not have things like object-oriented programming. C does not have things like string processing. And I want to add all these nice language features to make the language a little nicer. But sometimes it comes at a cost. And that's always the big battle. Remember, it's always a trade-off. You either get a language that's really, really fast and really hard to write, or rather, you have to write a lot of stuff, or you get a language that's extremely easy, that often takes one line of code to do things. That's your Python. Drill asks, what was B lacking that C was needed for? I don't have an exact answer for that. However, I will say that the first C compiler was written in B. So I'm guessing that C was probably just a modification of the B language that Dennis Ritchie believed, was sort of the best way forward for C. And we have some. Okay, I'm gonna stop the Q&A for right now because a lot of these topics I'm actually gonna cover. So let's jump into the main content here. Because I have an actual list of things here. So let me do that. Bam. Here we go. So the C history sort of starts out with Dennis Ritchie, and this will answer a couple of these questions that are in the list already. Dennis Ritchie wrote C, but Dennis Ritchie and Ken Thompson wrote Unix. So C was sort of originally created to build applications for Unix, and what it was later used for was to rebuild the entire Unix kernel in C, and that was sort of its first biggest project. From there, people started building lots of stuff with C, and lots of stuff with like GCC, which is now this massive project for compiling C on Unix-like systems. But that's sort of where it got its start, and C's been around for a long time. Remember, it was developed internally at Bell Labs, I think, in the late 60s. And then it made its first appearance in kind of the public sphere around the mid-70s, around 74, 75. So this is an old language. It's coming up on 50 years. And it's had a lot of sort of changes in the beginning, but then it kind of stopped changing. And that's something that's kind of miraculous, is, our... As consumers and as developers, our sort of expectation for technology is that it continues to improve, and that over time you have something that is 10 times as good as it used to be. And this is true with technology, whether it's hardware or software. However, C doesn't really fall under that category, and it's not because they didn't want to improve it. It's because they knew if they did improve it, it would come at a cost. So what happened in, the language was kind of first made publicly available mid-70s. It wasn't until 1989, which we call the C89 standard, that it was standardized by ANSI, the American, I forgot what ANSI stands for, National Standards Institute. Yeah, American National Standards Institute. They standardized the C programming language, and we call that now C89 or ANSI-C. And that was kind of the first standard version. And by standardizing it, something very important happened. They put out the C standard, and that allowed different compilers to implement the C standard to make C more portable across systems, because that's how you get C code that executes on Linux and Unix and Solaris and Windows and Mac and the litany of other operating systems out there. Is you apply the standard to your compiler, and then it works across everything. Now, there have been later C versions. C89 is kind of an old version, but you know what? C89 is a really good standard of C. It's good, and it's what a lot of people, even today, still aim to execute. And keep in mind that you're not using C89 because you don't want to upgrade. You're using C89 because upgrading would break portability across systems. That's the problem. Of course, you can go and download the C11 compiler, which is a full 22 years newer than this. It's just, is your software as portable as it would be if it's written in C89? And that's kind of why that exists. There was one major upgrade. It's like C89, C90, and then there was another upgrade in C99. In 1999, C got another new upgrade. But you know what? Since then, not a whole lot's been added. About 20 years went by with nothing major being added. And this is the miraculous part, is the language was kind of regarded as perfect 20 years ago. And since then, a lot of code that's being written in C is compliant with sometimes C89, but oftentimes C99. The only people using higher versions of C are people that both control their compiler version and their target system. But not a whole lot of people are writing portable C code in really, really new C. Kind of cool. Yeah, you cannot improve perfection, he said. And it's tough to make small things perfect because the C language it's not that big. You know, when we compare it against something like the Python standard library, which has just a litany of things built into it. You know, C has a very small amount of things built into it. They defer a lot of the decision making to the developer. And even a lot of the standard library that's part of C, which we're going to look at here in a second, some of the code, even a lot of the standard library is just written in C anyways. It's just things that are just added for you. But you know, C has a lot of basic functions that let you create really complex things. And so we're going to talk about a couple things here. Let me just take a couple questions. Hassan Muhammad asks, is C advisable to learn as the first language? So I think if you want to just get started with programming, you can kind of just ignore C for right now. However, if you want to be a well-rounded technologist that is really up on what's going on and really have a deep understanding on kind of how languages like Python exist, because remember, Python was written in C at one point. No, it may not be anymore. Well, actually, the C Python is written in C, but there are other implementations. But if you want to be a technologist that understands the full history of everything up to this point, then you really need to know where things come from. So C needs to be on the list of things to learn for all serious technologists that want to feel like they know how we arrived at this point. And learning C also helps you with another thing. It helps you understand how like Python code is executed, or JavaScript code, or even any other language that's based on a C compiler. Is, you know, like when I write a print statement in Python, I already have in my head what the corresponding C code was that underpinned that print function. And when you know this, you can write better high-level code. Danny Mexon asked, does C make you a better programmer? Should every programmer write in C at some point in their career? So I answered the second half of that, so I'll answer the first half of it. Does it make you a better programmer? Yes, it does, because C teaches you about types. C teaches you about doing things the hard way. And once you've done things the hard way, it becomes really easy to do things the easy way. So, like, actually, when I started out my career, you know, I started programming in 1994. And I started with only high-level languages. I started with Visual Basic, and then I moved on to PHP in the mid to late 90s. And both those languages are, you know, dynamic languages, or at least I think Visual Basic 3 was. That was so long ago, I don't really remember. But I didn't really start working on any statically typed language until later in my career, and I feel like that hurt me. I feel like it was shell shock when I went from something like PHP to something like C. It was totally just blowing my mind. So if you have the ability to start from a hard language and go to an easy language, it's super easy. When you go from C to Python, it's like, oh, well, this is really simple. I don't have to worry about anything that I was, previously worrying about. So does it make you a better programmer? Yeah, I think it does. So Pukar Gary said, shouldn't Ritchie have kept a simple bounds checking into C and spared us from the pain of buffer overflows? The answer is no, and that's because buffer overflow checking would be a runtime check, and that would add additional cost. And the second thing is anything that occurs outside of the C standard library, like anytime you use things the wrong way, we call that undefined behavior. And undefined behavior is this concept of sort of anything can happen. The joke has always been, anything can happen up to and including complete formatting of your entire hard drive. And that's always been the joke is you allocate 5 bytes, you access the 6 byte, and it reformats your whole hard drive. Of course, that doesn't happen in practice, but that's always been the joke, is that undefined behavior causes anything to happen. However, people often accept that undefined behavior exists. And the other thing is when you're working with C, like memory can come into play from other locations, like shared memory can be added. So just because the bounds checking doesn't exist in your program does not mean that memory doesn't exist. So adding a bounds check, probably not appropriate. So I would say no. No, he shouldn't have done that. It's good that it doesn't check it. But you got to keep in mind as well that and maybe this is a good point to jump into is, C has manual memory management. Let's just jump into some code real quick. Let's just write something simple. So what I'm going to do now is I'm going to create a Charles Smith, thank you for the 10. I really appreciate that. I haven't seen you here before. Welcome to the stream if this is your first time. So I'm going to create a simple string. I'm going to create a character array. I'll call it name. And I will allocate 32 bytes to that string. And then I will copy my name into that string. So in this case, what I've done is I've written a string into an area of memory that's 32 bytes long. And if I try to access the 33rd byte, one of two things will happen. Now, if I access memory that's owned by my program, all I've done is I've corrupted my program, and now kind of anything can happen. If I access memory that is owned by another program on the system, the operating system will smack it down with a segfault and say you can't access this area of memory because it's owned by another process. So, but if you know in your program that even though I allocated 32 bytes, I know 64 is available through some other means, maybe shared memory, then sure, right past that bounds check. And so it's only a huge deal for your own program. The operating system, whether it's Windows or Linux or Mac or Unix, the operating system is always going to prevent you from messing up the operating system state and screwing with other programs' memory. So in that case, it's no big deal. Okay. So I wrote a simple piece of code here, and I can execute it by... So let me just print this out. Actually, let me back up. I just did that as an example. So the next sort of topic is, we're talking about the manual memory. This is one of the things that people get hung up on with the C language and also C++, which I want to say is really the only two really common languages that still have manual memory management. So with C and C++, what you have to do is you actually have to request memory from the operating system. You can't just do, like in Python, you do like name equals engineerman. And internally what it does is it allocates the memory for you and it puts that in the memory and then you're good to go. But with C, no such thing exists. In fact, C does not even have strings. No such thing. The only thing C has is this thing called character arrays. which we're going to cover here in a second. So, but with manual memory management, you have to request memory from the operating system. So if I want to create a character array, I do char. I use a star for a pointer. I say name, and then I use this function called malloc. And what malloc does is it allocates me memory. I'm requesting from the operating system, please give me 32 bytes of memory. So what I do is I say size of character times 32. Why is Discord spamming? Let's see. Oh, okay, it's just a mention. All right. Okay, cool. So in this case, what I'm saying is operating system, give me 32 bytes of memory. Now, the size of one character is 1 byte, so this is actually 32 bytes, but if I had done like size of int, then this would be larger than that. So in this case, it says give me 32 bytes. So the operating system says, here you go, have 32 bytes. However, I do have to check to make sure that the operating system actually even gave me those bytes. So I got to do if name is null, then at this point this is an error. I now know that the pointer is null even though I requested memory from the operating system, and if it is null I have to end the program because that often means that the computer ran out of memory, and that's now an error condition. We won't do that here because it's just a bunch of extra code, but you do have to write this code. You got to request memory, you then have to check to make sure the memory actually came back to you, and then once it does come back to you, you can now use that memory. And that's what we'll do now. So right now, name is a pointer to the first location of a memory block of 32 bytes, allowing us to put up to 32 characters in it. And this is kind of what we'll do now. So if I want to put something into name, and again, this is, we're doing things the hard way. This is C. If we want to put something into name, we can't just say name equals. That doesn't work because C has no strings. So you could either do, like if I wanted to put engineer man, I could do name subscript it was 0. I could put an E, and then I can put an N, and then I can put a G. I could actually do it this way, and I could just load it all up like that. But that's ridiculous. But remember, we're operating on bytes, not strings. But C does have string functions. You might be saying to yourself, wait a second, why does C have string functions if there are no strings? And the answer to that is C can simulate strings by using what's called a null terminator character. So if you have a memory block of 32 bytes and you put the name, like we'll just say Brian, 5 characters, you put Brian in there, on that 6th character you could put a null terminator. And what that null terminator does is it tells the C string functions that this is the end of my string. So if you run like stringlen on a string with Brian in it and a null terminator, it'll tell you 5 because it's just reading to that null terminator. It's kind of an interesting kind of thing, but we don't have to do strings like this. So one string function is called string copy. And what string copy allows you to do is allows you to copy a string into a memory location. So you specify the name of the pointer, you specify the string. No problem. Now internally what this is doing is it's taking that string and it is converting every letter to a character byte, and then it is inserting it into the proper memory location, and then this function also automatically adds the null terminator. So really what we have here is, E, let me just make this smaller so it's easier to write. So we can think of our memory as looking like this. So we got B, R, I, A, N, and then we have a null terminator, which is a \0. So this is kind of what our memory looks like right now, and then we have a bunch of empty memory, up to 32. And once we've stored that in there, this is kind of what it looks like. And then now we can operate on this as if it were a string. Kind of cool, right? And the same thing is true if we print it out. So printf, by using the %s modifier, we're telling it that this is a string, which means that it'll read up to the null byte and then output it. So we can run this program real quick, hope it works. Maybe it will, maybe it won't. There it is. So it just says Brian. Perfect. So kind of string, kind of not. Now people might be asking, what is this little guy here? What's this little star? So this brings us into our next topic of pointers. So in C, this concept of pointers was created, and the whole purpose of a pointer is because a long time ago we didn't have 128 gig of RAM. We didn't have they didn't even have like 1 gig. You know, they were working in kilobytes worth of RAM. And the problem was, if you were operating on any significant amount of data, you couldn't just pass that data around as a value. So pointers exist to be able to say, I'm going to write a bunch of data in memory, and then rather than passing all of this information as a value, I'm simply going to pass it this little tiny pointer that points to that data. And it's kind of a cool thing. So imagine I have an integer. We'll call it age equals 30. And you'll notice there's no star. If there's no star, it means it's not a pointer. This is going to be, and this is read backwards, like age is an int. You know, name is a pointer to character. So you read it backwards. So if age is an int, then age is on what we call the stack. And the stack is going to be space in C that is limited, but very fast to access, and it's good for holding really small pieces of info. But you wouldn't want to store anything major on it. The stack space is only limited to about 8 meg, 10 meg, something like that. Beyond that, you want to store things on what's called the heap. And every time you call malloc to allocate space, you're receiving a pointer on the heap, or a pointer to a place on the heap. So we have an age. Now what we can do here is we can create a pointer to int, and we can point it at age. So we'll do like int page, and then now what this is page is a pointer to int. And then what we can do now is we can take the reference of age and store it here by using ampersand. So what we now have is we have page, which is a pointer to this original age variable. And it's kind of cool now because we can either change the variable directly, or we can use the pointer to access that variable. So we'll, in the first case, let's just output the current value of age. So if I run this, you can see that it outputs 30. No problem. But now what I can do is I can use page to update that variable. However, I have two things here. I can't just do p_age equals 29 because this modifies the pointer. If I want to access the value that is pointed to, I use a star, which is called the dereference operator. So this is really saying is, let me access the place that this pointer points to and change that value. So if I output age again, you can see now it's 29. It's been changed. And you'll notice that I output the age variable, not the pointer. So, kind of cool. Kind of cool how that works. But that's the basic of pointers. The reason this is a pointer up here, this character array, is because character arrays and pointers are kind of similar. And a character array is nothing more than an array of characters with a pointer to the first character. And that's exactly what this is. So name points to the very first character in that particular character array. So let me have a look at some questions here. Let me catch up real quick. Look in the chat. Yeah, thank you. Old school 978. So I hadn't got to that yet, but it's probably a good segue into it. So old school 978 said, just remember to free the memory at some point in your code. So he brings up a good point. The important thing about freeing is that when you allocate memory, that memory is held by your program for the entire duration of your program. And if your program runs or is intended to run indefinitely, this is where we get into a memory leak kind of problem, is that not only are you required to request your own memory, you're also required to notify the operating system when you're done with that memory. So in this case, I allocated 32 bytes on the free store. I put Brian into those bytes. I outputted the name, and then now I have to call free on name. And what the free function does is it says, I'm done with this RAM, have it back. I no longer need it. And that's exactly what the operating system will do. In fact, all free does is just let the operating system mark that memory as being able to be used again. It doesn't actually zero it out. And malloc also does not zero it out. So like malloc contains a bunch of, we call it garbage. You know, garbage is just old memory that has a bunch of, well, garbage in it. So you got to sort of keep that into account. So I should have probably talked about types. I want to do that real quick. There are not that many types in C. There's actually only 4. There's I should say primitive types. You know, there's an int, there's a float, which is single precision, and then there's double, which is double precision, and there's a character type. The funny thing about the character type is the character type is also an integer. It's an integer type, stored between -127 up to 128. And that's where the whole like ASCII table comes in. So if you store an A, you know, in a character, you're actually storing a, let me see here. Got my handy dandy ASCII chart. So like in this case, I'm just going to burn some retinas for a second here. So, you know, if you store an A, what you're really storing is a 65. And that's what's actually, you know, in memory. That's why the character type is of type integer. It's because you're storing a 65, which can later be converted to an actual character. Let's see, pointers let you use places in memory. If you can format your types, functions. Yeah. Yep. Okay. So another thing is we did pointers. Now we're talking about no abstraction. So in C code, we don't get things like classes. We don't get things like method scope. We don't get things like generics or templates or really any really nice stuff from other types of languages. You know, like there are languages that are leaps and bounds above C, you know, but again, they come at a cost. The one thing you do get in C is you get a struct. And a struct or a structure acts kind of like, I mean, it's not a class by any stretch of the imagination, but it does help a little bit. So with a struct, what you can do is you could say like struct person, and then in the struct you can place a number of things. Like you can place an int age, you can place a character array name, you can place a, you know, float, whatever. You could place a bunch of stuff in here, and then you can do things to the struct. You could place different pieces of value in here, and you could also include structs and other structs. So this is a way of creating kind of better data structures. They don't quite resemble classes, or it actually, what this really closely resembles is kind of like an object. Like think of like a JavaScript object, or like a Python dictionary that can hold, you know, predefined keys that contain different values. This is kind of like that. And then to use a struct, you know, you just do struct person, you know, em. And you can do em.age equals, you know, 24, whatever. em dot whatever 7.1, and then you can string copy some stuff into em dot name. So this is a way of taking a struct and then adding information to it. And then, but this is a struct that's on the stack. If you want a struct on the free store, you could do, it's kind of the same thing. I'm just going to copy and paste it. The only thing it changes is you add a star. And then instead of a dot, you'll do a dash caret. And the reason that exists is because once, oh, I got an malloc. So size of struct person, times 1. And of course, this is pointless. Size of struct person and size of struct person times 1 is the same. I like to do the times 1 just to say that, oh, I need 1. I just need 1 of these, and that's it. So this is a good way of kind of reading it as I only need 1. So the reason it's necessary to do this dash caret is because remember earlier where we dereferenced? The reason that, like, I can't just do em.age because I'd be accessing the pointer, and the pointer doesn't have a property called emAge. And so what I'd really have to do instead is I'd have to do parentheses asterisk em, which would dereference it to get me the struct, and then I could do dot age equals 24. So these two things would be the same. But the thing about that is this is ridiculous. This is ridiculous. This isn't the right way to do it. Let's just run it real quick, make sure it's good. It's probably broken. Conflicting types for em. Oh, I don't want em. I need em2. There we go. So it works. It compiles fine. So this is how you would have to do it, and they just said like this is not cool. This is dumb. So we're going to make it something simple, which is dash caret. And dash caret automatically dereferences what it's pointing to in the context of structs. So it makes it easier to work with in this case. But these are essentially the same, and then just like before, I should free em2. That way I give it back. Now it's important to understand that when your program ends, all memory is freed. So it's not like if you run a program and you don't free it that you've created a memory leak. Memory leaks come from malloking memory and then never freeing it, and then your program continues to run even though it doesn't need it anymore. This is particularly bad in loops. Like if you know your system's continually looping, creating new memory, then you can quickly run your system out of memory if you fail to free it, and that's not good. And once it runs out of memory, your program crashes, and that's the end of that. In some really severe cases, it might crash your entire system, but that's less common. So this is how we did a character array, but the same thing is true if we do like an integer array. I just wanted to do something involving integers real quick. So remember, this is int age equals 24. That's one age. If I want to do an array of ages, I can do int star ages. And then again, if I want to allocate 2 ages, size of int times 2. And then I could just set the ages, just as I would. Like ages 0 is 11. And this works all the same. Printf %d for digit, %d. And I can do ages 0 and ages 1. And this should output our 2 ages, 11 and 22, and it does, 11 and 22. So this is a way of doing arrays, kind of. This is an array of int. Ages is a pointer to int. But if you allocate more than one int, you have more than one int to access. And you can set it directly like this, because remember, an integer, it's already an integer type. The reason we have to use string copy for strings is because we're copying, like em2 for instance is 3 bytes, we're actually copying 3 bytes into place. But if you just have a single byte to copy, or a single thing to copy, then you could just add it directly. This is perfectly fine. So that's kind of an array like that. Let me check my comments. I am going to get back to that bootstrapping question. That's probably going to be the last thing we talk about, is the bootstrapping stuff, because it's such a fascinating topic. I love talking about it, and it's something a lot of people don't realize. So the last thing I'm going to do in code is talk about unions. So a union is the closest thing you're going to get in C to what we would know as a dynamic type variable. You know, like as you know in Python, you can do A equals 1, A equals ASD, A equals true. Oh, speaking of true false, C has no Boolean. No such thing exists. There is a Boolean type that was added in later versions of C, but in C89 there is no such thing. You just use 1 or 0, or you can use typedefs to typedef true to 0 and true to 1 and false to 0. But there is no true here. You would commonly just use 0 and 1. So the way unions work is unions are kind of like structs, but all the data exists in the same area of memory. So if you create a union, we'll call it union variable. In here you could do things like, you know, int ival, you could do float fval, you could do double dval, and then you could do, you know, like character sval, set it to like 64 max. And what's interesting about the union is when you create a union, so like union variable var, like if you set ival, for instance, you know, we'll set that to 1, and then we'll set fval to 2.2. If I now try to output the value of ival, you'll see something interesting will happen, or at least it should happen. So keep in mind, I set ival to 1, fval to 2.2. Oops, hold on. See what happened here? What is 107458685? What is that? I didn't set that anywhere. So that's the garbage you get from accessing ival. Because once you write a value to fval, it kind of just corrupts the data in ival. So what you're seeing here is corrupted data. But if I were to comment this out, you'd see that it now works as expected. It says 1. So the good thing about unions is that unions are very memory conscious, meaning that this is only going to allocate the maximum it needs to store the largest value. So in this case, it's actually going to allocate 64 bytes plus however many bytes for the union itself. But I could actually lower this down to like, well, actually here, I'll just make it a pointer. So if I do it this way, even though I have 4 things that would otherwise add up to like, I don't know, 12, 11, like 14 bytes. The problem is the biggest one here is the double, which I think is at 8 bytes, or maybe it's 4. So this whole thing is going to be just 4 bytes is all it needs to allocate, because you can kind of think like you have ival, and then below it you have fval, dval, and sval, whereas with a struct you have ival, and then next to it is fval, next to it is dval, and then so on and so forth. So this is the closest thing to a dynamic variable that you're ever going to have. However, a union, you would also have to track its type. You'd have to say like, what is this thing's current type? You know, because if you set the fval, you corrupt all the other ones. If you set the character array, you corrupt all the integer types. And that's kind of that. Double is a long float, so 8 bytes. Okay, so double's 8. So this would allocate a total of 8 bytes, you know, versus 8 plus 4 plus 2 plus 1, which is a lot more. So if you're writing a space-conscious program, you know, unions are kind of invaluable. Okay, great. So the last thing I want to talk about is this concept of bootstrapping. Somebody brought it up, and bootstrapping's kind of an amazing thing. I'll just start by jumping to the end and say that. So GCC, which is the GNU compiler collection, it's the most common compiler on Unix-like operating systems, is the C compiler was written in C. Well, what? How does that happen? How did they write something in C that is needed to make C code? How's that work? So this is kind of the concept of bootstrapping. And if we apply it to a real-life application, we can say, how did we build hammers without a hammer? How did that happen? Well, easy. We took a hard object and we hit another hard object until we made that stronger, and then we used that object to hit another object until it got stronger, and then eventually we had tools, after doing that a number of times. And then once we have the tool, we can use that tool to build more tools. And that's kind of the concept of bootstrapping. So if you look back in the chain of languages, you'll see that there was some language that had to have been written with just straight assembly language. And then that language was used to make a compiler for another language. And in the case of C, the very first C compiler was written in the B language. And keep in mind that it doesn't take long to remove the target language. If you write just a little bit of B code and then you create the C compiler, you can then use that new C compiler to make better C compilers. And as you go, you keep adding language features, then eventually you have a complete compiler which you can use to write anything. But the very first C compiler was written in B. But then now you might be asking yourself, well, what was the first B compiler written in? Well, I think it was probably algol something. And then beyond that, what was that written in? And then if you track all this, if you track this whole chain of bootstrapping down to the beginning, you'll find that something was just written in raw assembly, which is the lowest possible language you can go that is still understood by a human. Assembly language has a one-to-one analog to things that execute on a CPU. Assembly, once it's compiled down to an executable, creates machine code which then executes on a CPU. But oftentimes it's a one-to-one. And so that's kind of that's the concept of bootstrapping, and this happens everywhere. It's not just compilers. Like if anybody's ever used CoffeeScript, for instance, or TypeScript, in JavaScript, like TypeScript is written in TypeScript. So most likely what they did is they wrote the TypeScript compiler in JavaScript, and then now they just write TypeScript, which can compile TypeScript. Kind of cool. And this is a good way of removing the previous language. And like Rust does it as well. The Rust compiler is written in Rust, but it was probably written in something else before, C or C++. I don't know the exact answer. And that's bootstrapping. Calix asked, what wrote assembly? So assembly is going to be, so Intel's going to do that. People that put out these processors are the ones that maintain the machine code. Well, actually, that might not be accurate. Hold on. It's a good question, actually. I'm not sure if assembly is per vendor. If somebody knows, they should put it in the chat. But either way, the assembly language relates to machine code, and machine code is going to be CPU instructions that are managed by Intel in the case of Intel processors, or AMD in the case of AMD processors. So let's see here. I'm just checking to make sure I'm not missing anything. Oh, I completely forgot about something that I forgot to talk about, is POSIX. So POSIX is an additional set of C features that was added kind of after the fact. And POSIX has certain compatibility and also has certain advantages over certain C functions. Now, as far as systems that are POSIX compatible that you can use, like Linux is partially, I think Mac OS, and like Unix and Mac OS are going to be fully POSIX compatible. Windows has some POSIX support if you use the right compiler. So, certain things have different levels of support for POSIX, but POSIX is really good because POSIX adds a lot to the, kind of standard library. Well, sorry, I don't want to conflate those two terms. You have the C standard library, which is like 20 header files and the associated functions. Then you have the POSIX library, which is about another 35 to 40. And POSIX often does things better than the C standard library. However, the POSIX library will always defer to C. Like if they're ever in conflict, then you get the C version. So it really is just an add-on. And like threads, a lot of people use these things called pthreads, and the P in pthreads stands for POSIX. And like the C standard library has its own thread header, but the POSIX threads are better and more portable, so people use that. But POSIX is an important thing. If you're looking at C and looking at features in C, you're bound to come across a header file that's not actually included in standard C, but it's included in POSIX C. And in 2019, it's pretty much safe to use anything in the POSIX headers, unless you know for sure the system that you're going to target is just a POSIX incompatible system, which there aren't that many. There's more systems that are fully compatible than there are no compatibility. It's really just Windows. Windows only derives its POSIX compatibility through its Cygwin compiler. Somebody also asked about different compilers. There's a bunch. Like GCC is most common on Linux. Clang is most common on Mac. And then Cygwin is most common on, I think Cygwin's the name of the compiler. I don't know much about Windows, as people know. It's the most common one on Windows. And then for various other systems, a lot of them are using GCC. GCC is probably the most widespread one, I would say. Anything that derives any functionality from the GNU, the Free Software Foundation, most likely is using GCC. Okay, we're a little over time here. We'll see if I have any quick questions that I can tackle real quick. Okay, got that one. Let's see. Other compilers. Okay, let's answer that. So you could. Okay, I think I answered them all. There were some other questions I didn't answer, but I answered them, I think, through the content in the video. So I'm gonna put up all this code to the GitHub repo. That way, if you want to download it and try it out, you could just clone it and then just run make. I put all the functionality to compile it just in make, so you can just run make and it'll output all this stuff. Make sure I hit all my notes. Okay, I covered GCC, POSIX, C89, Unix, type, structs. Okay, I think we're done. Right on time. We went 3 minutes over, no big deal. So, last thing I wanted to say is, on every stream, I like to let people know that we operate a Discord server. Somebody will put a link in the description. We got about 5,300 people on there, of which between 15 and 20% are active at any given time. So if you want to go further with this, or you want to chat with like-minded people who are, working on lots of different projects in various languages, you should certainly come check out the Discord server, chat with people on there. You'll also see me in there all the time. I frequent the server quite often. And I hope you guys go and check it out. But again, there's a lot of people that I see here all the time. So thanks a lot to the stream regulars that are always here supporting the stream, people that support the channel. Of course, thank you to all my staff who attend and help out with the streams. They make a lot of this happen. There's no way I can focus on chat and focus on the stream itself. So they're good about getting the questions to me and make sure I get people's questions answered. So I hope I got everybody's question. I did my very best to answer everything that I didn't cover directly in the video. If you do want to go further, and if I missed your question, please follow up with me on Discord. Place it in the. We have a channel for C, and should certainly put it there if you want to go further. Other than that, I hope everybody has a fantastic rest of their weekend. And for my American friends, happy 4th of July the other day. And I might be doing a video tomorrow. I might not be. I'm not entirely sure. But be on the lookout for additional content. And remember, let me know about stream topics and how you like the new Unity videos. Let me know in Discord or in the comments of this video so I can kind of know what I should work on. But other than that, I hope everybody learned a lot about C. We evangelize C a lot, and we like looking at history of, like software engineering history is just a terrific history full of a lot of really smart people and a really great technology. So, we evangelize that a lot here, and that's what this was all about. And of course, the name of the video was, an ode to Dennis Ritchie. Dennis Ritchie was one of the greatest technologists, and may he rest in peace. And people will pick up the torch from where he left off and continue using the language he built for the next 100 years, hopefully. So, but that's it. Hope to see you around, and have a fantastic rest of your weekend. Take care.